Okay. My screen should be up in 5, 4, 3, 2, 1.
Okay. Awesome.
All right.
Now we can see.
Great. So, before I jump into anything, I'll just give a brief introduction of myself in like a minute, just so we're familiar. My name is Damilare, but everyone calls me Dami. So please, Dami is what you call me for the rest of this call and whenever we meet. Currently, I work as an AE at MCOPA. MCOPA is a financial institution. We do more than financials, but majorly financial institution majorly in Kenya, or we have operations in about 5 other African countries. Before that, I was at Sears, Roebuck and Co. That's in the US. And before that, I was at Carbon Finance here in Nigeria as a senior business intelligence developer. Today, I've been asked to sort of just do a discussion. I don't want to call it a presentation because that looks like me just talking and you guys listening, and I would like feedback from everyone. So today I've been asked to do a discussion on the modern data stack. And so the title is the modern data stack, as you can see on your screen, how we moved or how we pivoted from ETLs, which you may or may not have heard of, to something called the ELT, which is the modern data stack. So to start, I want to actually draw your mind or paint the scenario. I'm guessing everyone here has some history with data. So if we all have some history with data, we've all been in this particular scenario where it's a Monday morning or it's a Thursday afternoon, and then your director or your CEO wants to know why something happened. So as you can see on my screen, the director wants to know why retention dropped last quarter. And your data sources are in a lot of places. So you have data in Salesforce, your customer profiles are in like Salesforce. Maybe you have your transaction data in a SQL database, or you have customer support tickets on something like Zendesk, and product data somewhere again, maybe in an applications data warehouse. So you have your data all scattered, and your CEO wants one coherent picture. He wants to know what happened to retention last quarter, and he needs it by Monday. And that's the beginning of the problem. That's the problem that most data teams face in the real world, right? Since like the very beginning. And one thing I want you to notice about it is that it's not a technical problem at its core. It's more of a translation problem. And what's the problem? It's how do you take data that lives in several sources or several systems and in different formats? How do you take that data that has been built originally for different operational purposes? Remember, as you can see on the screen, we have different data, Salesforce, SQL DB, Zendesk, even in somebody's spreadsheet somewhere. Different data, different structure, built for different operational purposes. How do you take all that data and how do you make it useful for decision making? That is the problem. Now, that translation problem that I mentioned is the thread that sort of runs through everything we are going to talk about today. Now, like I said, from time immemorial, that problem has always existed, right? And the first serious systematic answer to that particular problem that the industry came up with was something called ETL. ELT is a more modern answer to that question. So basically, we have a problem. The problem is we have data in the source or in different sources. We want to make meaningful decisions. First approach, or the initial or the original approach to solving that problem was ETL, right? Now, the reason the answer changed from ETL now to ELT is not because somebody was suddenly smarter. Just right off the bat, I'll say it's because there are certain constraints that existed in the earlier days that are no longer constraints. And that is one of the driving force of ELT, ETL to ELT, but I'm getting ahead of myself. I'm going to talk about this in detail. So again, I just wanted to hold that frame in your mind that we had a problem, or we do have a problem in analytics. We want to make decisions, but the answers or the information, the data we need to make those decisions are stored in several sources. We need to get that data and we need to bring them where we can make decisions from it. We have two answers to that problem. We have ETL in the olden days. I don't want to say olden days, but the original answer ETL, and now we have ELT. So that's the frame I want you to hold in your head as we go through it. Now, I always say whenever I have the chance to talk about things like this, that we're not comparing the ETL versus ELT. It's not comparing one bad approach versus another good approach. I'm not saying one is good and one is bad. So before we say why we moved from ETL to ELT, let us talk about the original approach. Let's talk about ETLs first of all. Many of you may have, heard of ETL. I think it has even become like a verb. My former company, we use verbs like ETLing. So it's quite popular, right? And we're talking about something that started in the, I think, late 1900s, right? Where you had, data teams that needed to get that data from different sources, transform that data, and then load that data somewhere. So let's break down ETL mechanically first. It's an acronym, right? And it stands for extract, transform, and load. That's basically what it is. Extract. Oh, can I zoom in my screen a bit? Sure. Sorry. I have 4 eyes, so it's never a problem for me. Can you see it better? Now just give me a thumbs up if you can see clearer. Nope, not yet. Okay, great. Okay, thank you. So yeah, where were we? So I wanted to break down the ETL. So extract basically, and I'm going to just break it down in, maybe oversimplify it, right? Extract basically means we're pulling data from those different sources that we've mentioned at the start. So from your CRM, from your ERP, from Zendesk, from somebody's CSV sheet somewhere, from flat files, etc. We are pulling that data. So that's basically, simply putting it, that's what extract does, right? Pulling that data from your operational systems, right? And pulling it somewhere. Now, the T stands for transform. Now, before we load that data into a data warehouse where analysts or stakeholders can read from, we want to transform that data some way just to ensure that it is fit for analysis. So we want to clean that data, we want to do joins on that data, we want to apply business logic to that data, and just maybe shape that data to the right format before loading it. Now the L stands for load. So now we've transformed the data. The data is clean and fit for analysis. We would load that data into a final data warehouse where analysts can pick up that data and run simple SQL queries and get results from. The key thing to note is in the ETL, transform happens before load, right? So you have to have transformed that data. So the usual structure is this. We have raw data in those sources. We take that data. We usually do this transform. So we usually extract this data to somewhere called like a staging layer. So it's usually like a small internal storage where we apply this transformation. And then once that transformation is done, we load. And then we clear that external storage or the other storage where we do the transformation. So we're not storing the raw data per se. We're just transforming, and then we are loading the final cleaned data into our data warehouse. Now, the question is, why did it make sense at the time? So yeah, you can see my schematics here. You have the source system, you have the transformation happening here, and then you just goes into the data warehouse. Now, the question is, why did it make sense at that time to actually do it this way? Now, it wasn't really, I wouldn't say it was bad engineering, right? Or lazy thinking. It was actually like a well thought out solution for the constraints. I mentioned constraints at the start. For the constraints at that time, it was actually like a well reasoned solution. There were three things, as you can see on your screen. One, back then, storage was genuinely expensive. So when I say expensive, I mean expensive in a way that is it's very hard to appreciate today how expensive storage was. So we're talking about companies having like on-premise servers, physical hardware that's so just like your normal hard drive. Physical hard drive is just me oversimplifying it, but physical hardware that your company bought and racked somewhere in a data center and maintained. And because again, storage was expensive, it didn't make sense loading raw, messy, unprocessed data into your data storage because you're wasting expensive, limited storage on data that was not useful yet. So the logic basically was to clean that data, only load what you need in your data warehouse in the exact shape that you need it. So storage was very, very, very expensive. Also, compute was also limited. And it was not just limited, it was also a shared resource. So your warehouse sort of ran on a fixed hardware. So for example, if you try to run like heavy transformation queries in the warehouse, you were competing with like analysts and BI tools that are also simultaneously trying to read from it. So again, compute was limited and was shared. So if I am running something, Aya is running something, and maybe I'm going to pick somebody, and Deza is running something, we are all sharing from one compute. And it sort of causes, I think it's called queuing, right? You have issues like queuing on that data warehouse. So those are some of the issues that we had. So these two constraints, basically, storage and compute, was something that ETL itself tried to work around. So we basically are not loading data that we do not need. So like I said earlier, we have the raw data from the source in the source systems, whatever systems they are stored in. We bring in the data we need to transform, put it in a staging layer, do our transformation in that staging layer, and then load our final cleaned, pristine, transformed data into our data warehouse, just what we need, nothing more, nothing less. So we don't load data we don't need, right? We also don't run heavy transformation inside the shared compute again, because we have the shared compute, and one person running heavy transformations impacts on other customers of that particular compute. Now, in this particular ETL era, we had different tools that were used, and okay, well, I did have another issue that I highlighted here. So another issue was with the, maybe I shouldn't talk about this here, but okay, since it comes up, I'll just talk about it. Another issue with the ETL era was the speed of getting things done. So one thing we should know is the data engineer owns the entire ETL process, right? And is like the most important person. So he's responsible for extracting, doing those transformations according to the business logic and loading into the final data warehouse for customers. And so a business question may arise by the analyst, by the CEO, or a change in business logic even. So we may have a logic that makes sense last quarter. We're changing business logic now. And what happens is what you see here. We create a ticket for the engineer, he picks it up, it takes days to do all that, changes, builds, tests, deploys, takes more days, then we finally get our answer. So the business decision or business changes was not done as efficient as it could have been, right? Um, just one the question. Hearing some sounds. Okay. So I wanted to just highlight some of the tools that of this era. You had tools like, and it's okay if you've not heard of any of all these tools, but I think the big names then were, oops, what is this? Sorry, Microsoft and Microsoft. How do I get this? Okay. Okay, now I've done it. Sorry. Okay. Where was I? Where was I? Where was I?
Um,
My bad. Yeah. Does someone have a question?
no, I was saying that the tools of the era, that's where it stopped.
Yeah, okay, okay. I was trying to find the slide. So yeah. So we had like 4 big names, right? We had Talent, which I was very unfortunate to have used myself. Talent, SSIS, I've never used SSIS. Informatica, I've heard of. Ab initio, I've also heard of. And these were like some of the big ETL toolings that we had. They were expensive, they were complex, they were powerful, won't lie. But basically, those are like some of the ETL tools that we had. We had some as well with like AWS Q. I think that also does ETL. I've never used it personally, but that also does ETLs as well. So yeah, I talked about some of the another of the constraints was the ease of actually getting things done with the whole ETL structure. So what changed, right? What changed? And I like to call this like the inflection point. Now, between I think in AWS, Amazon rather, launched S3 in, I think, 2026, I believe. And when they launched, we also had the launch of GCS, that's Google Cloud Storage, and Azure Blob as well. And what that meant for the data industry was, one, storage became very, 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 in comparison, of course, to the previous way of doing things, storage became very, very, very cheap, absurdly cheap compared to what we had before. So think about what that means for like the core ETL assumption. The entire reason why we, transform data before loading it into the data warehouse is to avoid wasting expensive storage on raw, unprocessed data. Now, if storage is cheap, then you can now store terabytes of raw data for just a few dollars a month. And that assumption just goes away, right? The cost argument that we can't actually keep raw data or we have to transform our data before loading goes away, because now it costs next to nothing to actually store the raw data. So you can now afford to keep like every raw record exactly as it came from the source. Not because it's tidy, though, but because it's cheap. It's cheap enough that the cost of not keeping it actually outweighs the storage. When I say the cost of not keeping it, for example, we keep raw data because we want to have an audit trail. We also want the ability to always reprocess history. So for example, you want to do a backfill or something, you have the ability to reprocess history. So the cost of not keeping it sort of outweighs the few dollars you're going to pay in storage bill. That's one thing that changed, right? Another thing that changed is cloud warehouses like BigQuery, AWS, Snowflake now separates compute from storage. This is actually like a very big architectural shift, right? Because traditional data warehouses run on like fixed hardware. So your storage and your processing power were basically tied together. If you needed more compute, you just needed to buy more hardware, right? If your hardware was busy doing transformation jobs, it probably wouldn't be able to serve analysts running query. But when Snowflake and the other guys came, they sort of were architecturally different in a very critical way. So they separated storage from compute, and that changed or changes the economics of transformation. Now, if you can run your transformation logic as SQL in a scalable warehouse rather than on like a fixed ETL server, the cost argument also goes away. So when I say scalable, many of these cloud warehouses scale upscale and downscale depending on the demand at the time, right? So there's no that compute constraint is no longer there, right? Because what you want, how do I want to pay? What you want is what you will get because it easily scales up and scales down. Another thing that changed, and I would like to notice what the proliferation or the explosion of SaaS tools, SaaS is software as a service, right? Back in the early 2000s, right? Maybe you needed to have, maybe as a company, as an organization, maybe you were integrating data from maybe 4 or 5 sources at best. But by the 2020s, right, the average mid-sized company had data in myriad number of sources. So you have a particular company having integrations with Salesforce, with HubSpot, with Stripe, with Zendesk, Paystack, with Google Analytics and all that. So you have lots of sources. So now, software as a service has exploded, and we have a number of sources that companies have to sort of ingest their data from. Now, these sources are not databases you own, right? They are SaaS platforms with APIs probably, and building custom ETL pipelines to handle every single one of these integration is just an enormous amount of what I would call like undifferentiated work, right? Meaning it's important, but it actually doesn't make the company better at its actual mission, right? It's an important work. In my former company, we used to call it Yoruba work, right? It's important work, but doesn't really do anything for the company, right? So tools like Fivetran and Airbyte have tried to actually solve this problem by actually building connectors where you just connect to different software as a service sources and load that data into your data warehouse. So that EL part of the pipeline is done. You can use this Fivetran on Airbyte. Fivetran actually just merged with DBT. I'm really excited for that actually. So basically you can load or Fivetran has, I've used Fivetran a lot, so it has lots of connectors to many of all these sources, and you don't have to create custom ETL. I think they're called service ETLs. Can't remember the exact term for them, but you don't have to create custom ETLs for them. You can just extract and load it to your data warehouse and transform from them. So putting all these 3 changes together, cheap storage means that loading raw data is affordable, very affordable, and can be useful. Scalable cloud compute means that transforming inside your data warehouse can be done fast, in a fast way and in a cost-effective way. Having connector tools means you don't need to start building your own extraction infrastructure. Now, I would say the question has stopped being, can we afford to store raw data, and has become, can we move fast enough once we have that raw data? And this is fundamentally, this is a different question and sort of needs a different answer. So ETL, I would say ETL is the answer to, because again, extraction and loading has been solved. Transformation now is the main question, and how fast can we transform and how best can we transform? So with ELT, rather, did I say ETL? With ELT, ELT, say ETL again, kind of solves for that. Now with ELT, the order has sort of changed. You extract first, you load, because now it's cheaper and it doesn't cost a thing. You extract first, right? You load, and then you transform in your data warehouse in SQL using tools like like DBT, right? I'd like to highlight, I think I broke it down into, so yeah, you can see here, okay, I have this cool HTML thing. You can see ETL here, you have ELT here. So you extract first, load the raw data into your warehouse. Raw data is always in your warehouse. Then you transform. I think you guys are familiar with DBT. You know, DBT basically just sits under your data warehouse and transforms the data for you. Putting the raw data, and you have your raw data and your transform data in separate schemas or separate locations. I think next I want to talk about how we doing so far. Questions are asked. Okay, I just continue there. So I've sort of broken it into the 3 layers. The first one is ingestion, then storage, and then the transformation, which I think we've talked a lot about. Another thing I want to talk about, and I think I've touched on it, is why do we actually need to preserve the data? Why keeping the raw data? Why is it such a big deal? I know I touched on the need to reprocess data. If the need to reprocess data occurs, right, we would always have that data. So in the ETL world, right, like we said before, raw data, right, was just like a means to an end. Transform it, dispose the raw data. In the ELT world, just repeating it again, the raw data basically is like a safety net for you. It sits in your warehouse in the exact way that it comes from the source, so you can precisely see what the source system said at a given time. I'll give an example. I work in finance, so it's probably going to be like a finance example. Our backend produces some source data, and then we ingest it and just as is from the backend database and load it into our data warehouse, right? What having the raw data means that even if something happens at the backend database, I have the data that is produced per time from the source. So if, God forbid, that can even happen, but if backend loses their data, I'm not depending on backend for the source for historical data. I always have that data somewhere in my data warehouse, and it costs me nothing to actually keep that data. In case of a business logic change or something, I do not have to, in the ELT world, I would have to re-extract that data again. Because again, remember I said in the ETL world, keep mixing that. In the ETL world, I would have to re-extract that data again. Remember I said how ETL works is we extract into a staging layer, we transform in that staging layer, and then we load. Once we're done with that transformation, we clear off the staging layer, so we don't have the data staying in the staging layer anymore. In an event that we need to do, maybe change the business logic or whatever, we need to do that extraction process all over again and apply the business logic, the new business logic in that staging layer, and then load again. But with the ELT now, we already have the source data in our data warehouse. All we need to do is just make the change of the business logic, maybe in DBT, and do maybe a full refresh in DBT, and whatever it is that we've defined in our transformation is propagated to our downstream models. I think it's almost time, but I don't know if I should cover this, or this was out of scope, but again, DBT, I just touched on some things for DBT. DBT's staging, model structure, how transformation in the modern data stack is organized. So we have the staging, which I'm sure you already know about. I'm just going to breeze through this. Staging, the intermediates, and the maths. Staging is just basically your raw data, maybe with light casting or whatever. Intermediates is basically where you define your business logic, and then maths. Usually I do my dimensional data modeling in my maths as well. I have 45 minutes and I have 3 minutes more, so forgive me if I'm breezing through this.
Damilare. Okay, you say we should
Yes.
do that. Yeah, you can go ahead, take your time. If there is any question,
Oh, okay.
I'll let you know. Yeah.
Oh, Oh, okay,
Yeah.
okay,
Yeah.
okay. So, with ELT, Rose, no, how am I going to put that in English? With ELT came the advent of the analytics engineering roles, which is basically what I do, and I think we all do, right? So with the old ELT structure, uh, the analytics engineering role did not exist before ELT made it possible, right? So um, in the as analytics engineers, we sit in the intersection of the data engineering and analysts or the stakeholders. And basically, we need to understand because we are chiefly doing the transformations, and these transformations are hugely based on one business, the business logic. So we need to have deep business context. We need to also um, understand the business logic, and we need to be able to express that logic precisely. Uh, we own the transformation layer, like I said earlier, right? We own the DBT projects, and that's right with this now. That's because we are closer to the business than the actual data engineer. The data engineer is more than anything a very a more technical person that's too far from the business. Just like my workflow and uh the workflow that I did show is quite far from the business, but with the let me paint the clear picture. So the data engineer is upstream of us, right? So they make sure our warehouse is running, they make sure our ingestion pipelines are healthy, our infrastructure is reliable. They think about all the compute costs, orchestration, depending on your company. In my company, I do the orchestration, but yeah, platform stability, etc. The analysts who is downstream of us, right? They query the tool and they are the ones that actually generate the insights from whatever data sets we are providing to them. Now we sit in the middle, and our job is to transition in both directions, right? We translate raw messy source data with all their inconsistencies. We transition that data into clean, well-defined, trusted models that analysts can then build on with confidence. So we also understand the business logic. That's why I said we are very close to the business. An example is for example, I work closely with the finance team and product managers too, because I have to understand the context of the business. I'm not just writing code. I need to understand why what is what, and even prefer alternatives that I think will best help these stakeholders achieve what they are trying to achieve. DBT, like I said again, is the tool that made it all possible for the analytics engineering role to become more prominent. And DBT brought like software engineering standards into data transformation. Standards like version controlling. DBT used to have that prior to DBT. Yes, I said what I said. We didn't start that prior to DBT. Also, DBT also introduced testing as well to code. So DBT, again, I mean, don't be preaching to the choir right now because I think you guys are familiar with DBT, but DBT also incorporates data tests. That way we can assert that certain things should never happen to certain parts of the data. Another key thing with DBT is the documentation feature, right? That allows us that generates like a searchable data catalog from your SQL models, your YAML file, etc. Now these three things together, they help us or help the analytics engineer build like a data that everyone can trust. Now, this was the part I put for. Okay, I wanted to like spend like a few minutes. I wanted to spend. Nah, this one is not that there. I wanted to spend like a few minutes just to mention some honest trade-offs. So, just in the just being honest, right, about, because I'm all for the ELT. I mean, practically is my job, but being honest about the whole data stack thing. There are some trade-offs that the introduction of the ELT brings to light. Or one, even though we are compute costs and storage costs are now considerably lesser, one trade-off is compute costs are also very real, right? Compute costs are very real. So as an analytics engineer, or as someone that uses the modern data stack, the fact that I've said, oh yeah, it's cheaper, load everything, compute costs are real. And one thing that would really spike your compute cost is poor model design, like I've said here, or aggressive scheduling of your model refresh. So one thing you should know at the back of your mind is that every query you run has a cost attached to it, and a well optimized project running like dozens of large full refresh models every hour can generate invoices that would surprise you. Trust me, I know. So usually when a team takes on DBT, they get really excited and start building a lot of models, set up like really aggressive refresh schedules. And someone, looks at your snowflake bill at the end. Snowflake is really crazy about that. Someone looks at your snowflake bill at the end of the month and it's crazy. So even though it's cheaper, but one thing you should note, and this is like a takeaway I'm leaving with the ELT data stack. One thing you should notice is that compute costs are very, very real. So ELT doesn't really just make all our problems go away. So if you're building in ELT, one thing you should make sure is, one, your model designs are very, 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 very intact. Try as best where possible to use incremental models, things like incremental models, so doing full refresh on everything. Try using some warehouses allow you to have smart partitioning, so you do not have to query everything. And BigQuery has that. Sensible scheduling. So if your data doesn't have to be real time, so you don't have to refresh every 10 minutes, right? So you and your stakeholders should know what people say fresh. Like my director will tell me, oh, we need this data fresh. What it means is that it needs to see his meeting is every Monday, and he needs to see it by 8 a.m. on Monday morning. So fresh for him is as long as he can see it by 8 a.m. on Monday morning. So maybe I refresh that table on a weekly cadence instead of doing it every 10 minutes. So compute costs are real. That's the first thing. The next thing I want to notice, the raw layers now become a dumping ground. And that's because people say, oh, you know what, we have to ingest everything and then we'll sort it out later, right? The principle of that loading and preserving raw data, I mean, it's sound, but in practice, people get carried away, right? And just ingest everything and then we'll figure it out later. And then 6 months later, you have like 450 tables in your raw schema, and half of them are like from systems that your company stopped using in 2024, right? And nobody knows what the table STG, table export V2 means again, or where it came from. So raw layers can fast become dumping ground. So basically your raw layers would eventually need to have very strict governance. Your schemas would need documentation. All your stale sources would need to be deprecated and removed. And it doesn't happen on its own, right? It requires discipline from the data team itself and basically from the rest of the data infrastructure. Also, data quality surfaces closer to the consumer, right? In ETL, when there's a broken or a malformed source, it will fail the transformation job, and you would find out because the data broke or because the pipeline broke, right? You know you feel quickly when there's a data problem, right? It feels really quickly because feels and the transformation. The end users probably wouldn't see it. Maybe they would experience late data, but they wouldn't see that data quality issue. In ELT, you've loaded the data, and bad data can make its way to through your transformation layers if you don't look out for it to a live dashboard, for example, before anybody notices, and then you know point it out to you. So data quality problems surface closer to the consumers, and that's one of the trade-offs you're making with ELT. I want to say documentation is easy, but then documentation depth, I call it documentation depth, similar to your technical depth, right? It's and this is something I've experienced on my own thing personally, where if documentation is not enforced, you wrap up documentation debts easily, because again you can create 150 models in 6 months, and because you're just creating your thing and just moving on, you forget that you have to actually document it. Documentation that's accumulates really fast. Now I close by saying this. First, okay, well, I want to talk about where I see it's going. Because one thing I want you guys to understand is that the tech field in general is like a moving train. It's always going. So first, one thing I see is the line between batch and streaming data as time goes. The ELT described today is fundamentally batch, right? So you look at the data, you transform it, you refresh it. Well, businesses want fresher data, and tools like native streaming supports in BigQuery, for example, and database lab, all systems are starting to bring systems like database, for example, are starting to bring ELT style development patterns to streaming workloads. That's something like that's a shift I see happening in the future, where we have ELT patterns to streaming workloads, and I think Databricks is fast moving, and Databricks most especially, I think it's fast moving in that direction. So we are also, with the advent of the lake house, basically there's a distinction between data lake, data warehouse, and that distinction is hugely dissolving with the advent of the data lake house, and that's something snowflake is also moving towards, right? Let's see. So after I people about this forward, and this is me around, is understanding why the stack looks this way right now is matters as much as knowing how to use it. So I think now we've discussed why we moved from, I think everybody understands why we sort of pivoted from ELT to ETL to ELT, believe me. But more than that, you also know you also have to know how to use this particular stack. When you know that ELT exists, because you don't cheap and warehouses are more affordable, and you understand why the cost optimization is part of your job. When you know that DBT exists because transformation needed to be owned by people that understand business logic and just infrastructure, then you understand why documentation and testing are also not extras, but are also core or important to your role. These are the things that make you like an excellent, or these are the things that make your role as an analytics engineer very legitimate. It's not just knowing why, why the ELT data stack exists, or also knowing But I think that it's also important to use the ETL stack. Also knowing, that you also have to understand business logic. So the two and are not just arbitrary, right? Every major design choice in the modern data stack was made like in a response to the constraints that we've talked about. And hopefully, now that you understand why, it makes you a better engineer, more effective communicator. I would say a very effective communicator, but yeah, makes you a very effective communicator. So I'll say thank you very much at this point. I've sort of rounded up. I'm very poor at this speaking, sorry. So my editing, I'm still working on it. So if you have any questions, then I am more than happy to take them.
All right, all right. Thank you so much for this session, Damilare. Right, I think this topic I'll go and speak about it as well, right? Because you did justice, honestly. And one of the important things that I do teach is know the reason why you are doing something. That's the most important thing, right? A lot of people want to do ETL without really understanding why are we, doing ETL and whatnot. And summarizing most of the things that you talk on, especially around costing, which I think was the major reason why, organizations do not want to keep the information that they had earlier, right? But now, my question basically, which I got from some people is, why are we keeping the data now? Whether cost is associated or not, aside being able to like do auditing and all of that, right? Let's assume that cost has not really storage has not really become cheap, and then with the advent of AI, would organization still go ahead with saving their data while the storage is still a bit expensive?
So let me try and rephrase your question. We are saying in an event that storage is still as pricey as it was, but then
Yes.
with the advent of artificial intelligence, would companies still go about keeping the raw data? Just right
Yeah.
off the bat, I want to take our mind back to, so when we say storage was expensive, back then we were not talking about having your data in cloud, and it was expensive. One thing you should know is this: the more storage you want, storage was basically hardware at that point in time. So the more storage you want, you have to procure hardware, and hardware comes with a lot of overhead costs. You had maintenance costs. You had basically they are fixed costs aside maintenance costs, because you had to put that storage somewhere. So assuming storage was still hardware and was still as expensive as it was before, I'm having difficulties seeing how, first of all, one thing we should know is one of the reasons why AI is even how it is now is because storage is now the way it is. AI works on, it's based off of data that we've stored somewhere and it's trained with this data. So if the storage was just stored in separate monoliths and every organization had their own separate storage somewhere, that would even impact on AI. So I'm having difficulty seeing how the advent of AI would improve. So maybe you can help me. I don't know who asked that question, but maybe they can help rephrase that question in a way that I would get it.
Okay, so I think the person is having network issue, but drop it on my WhatsApp. So basically, I think what I understand from the question is that now organizations are storing data, right? Because it's cheap, right?
Yeah.
Now, most of these data are actually getting stored. Let's leave outside, auditing use case. Now, most organizations are looking at, they want to go into AI and all of that. So everybody wants to start keeping data, right? Now, let's not take it back to the old age where storing data is not cheap, will it still like be a valuable enterprise to go into, keeping data just because the organization
Okay.
might be looking to go into AI? Yeah.
Now I get the question. Now I get the question. So, okay, would it still make sense to keep the data just for the sole purpose of going
Or
into
you
AI?
doing so, yeah, exactly. Yeah.
That's now a business that's a business question. So the first question I would ask the business if I was like a consultant on that matter is, what do you aim to get? Are you going into the AI for clouds and just to put it on your yearly reports that, oh, we've gone into AI? What's the goal for going into AI? So if your goal for AI is maybe to improve efficiency, and then you can convert that your efficiency to cents and dollars, right? And say, okay, if going to AI, projecting that we can cut blah 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 cost by so amount, then you can juxtapose that cost with the extra overhead cost you're going to get with increasing or storing this thing. So you have to compare what you aim to get from implementation of AI with the extra cost it's going to cost you to actually store the additional data. And then if it makes sense, if the numbers make sense, right, then my advice would be, yes, of course, store as much data as you want, because again, it's for something. But again, if you can't put AI, is you're not just doing AI for AI's sake, right? If the additional gains you are going to get from implementing AI does not supersede the additional costs you're going to incur from storing the data you're storing to train the AI, then it's I think it's a very bad venture. So for that to make sense, whatever additional gain you're going to make from, or whatever additional profit or whatever additional cost savings you're going to get from implementing artificial intelligence in the organization should supersede, even even now that even it's not just when data is expensive or storing data. Even now that data storage is cheap, your cost of implementing AI should supersede whatever it's going to cost you to train the AI or whatever. So again, that's more of a business question. There's no one size fits all answer to that particular question. It's the organization should look inward and just project what they plan to do with that artificial intelligence, and in the long run, how much cost saving or how much profit or what's, it may not even be, it doesn't even have to be dollar and cents. There's something called I think it's called intangible and intangible. I can't remember the operational terms for that, but basically, the benefits should outweigh the costs for such companies, and that would be my answer.
Okay, awesome. Thank you for that response. So I think another question from me actually straight now is, which I think is literally what everybody is also looking for, is right now the most important thing that you can sell as a data person is understanding the business side, right? Now, nobody will teach you the business side, but how do you go about adding this business side to your tools of arsenal? So you don't go into meetings and you're the only person that is not on meeting is mic to contribute to what's being discussed. What are the books or the processes that that can help you to scale from know before, when you are looking for a job, what you have to know the tools. But now,
Mhm.
when you are looking for a job, you have to know the tools and then also know the business. Because now AI can even do the tooling for you, right?
Yeah.
So what would be your advice for people in that area? Yeah.
Okay, I would answer that question with a short story, personal story, because it's me, it's my life, it's my story, and it would help you maybe understand better. So when I started out in before I started out in data, I used to be a process engineer. So the normal, not the fancy computer ones, the hammer, saw, and everything. I used to be a process engineer at Golden Penny. And then I sort of transitioned into operational analytics, still at Golden Penny. So whatever data or business context I had was purely manufacturing, it's purely industrial, and that was all the business context I had. But then my next role, I started as a senior BI developer at Carbon. Carbon is a fintech. So at that point, I knew the tools. I knew MySQL. I knew Python, I knew all that. But then in a meeting, somebody talks about accrual interest brought forward, and I'm like, what the hell is, okay, what I know is capacity, watts, kilowatts per, those were the things I could come to terms with. And someone's mentioning balance sheet and stuff. So I was lost, and it's a very bad place to be in. Not bad, but I think it happens to everybody, but it's a very awkward place to be in because people, job has brought you on and they expect contributions from day one, right? And then there you are having zero context. So my approach to actually ramping up very fast was one, just humble yourself. That's one. Humble myself, and I had to be more. I had the option of working remotely. The technical department back then had, so we in data software engineering, we had the option of working remotely, but the operational guys would always go to work. So one of the things I did was start going to work every day, and that way I get to interact closely with these guys. So for example, if you come to me with something, I'll sit you down like, guy, sit down, explain this thing to me in simple English. Don't use balance, but teach me like I'm five. And then because I was able to build that rapport with people, I was able to understand terms very fast, right? Another thing that helped me was extra. I'm not even going to lie, extra study helped. I did Udemy course I did finance for non-finance managers. I did, so basically extra study helps, right? When you find yourself in a new space, just try to learn as much as possible about that particular space. Take short courses, have someone, be close to someone that's well versed in that particular space. Another thing that helped is the community. I had this, so I have this community where we have some data people. So another thing I did was always going to actually talk to people that I know that have been data people in the finance space for a while. So when I have an issue, I'm like, guy, please, balance brought forward. What does it mean? And then they sit me down like I'm a 2-year-old, and then they explain it to me. And with that, on my extra learning, I was able to ramp up pretty fast. So the best way to get context is understanding the business. It's like an anecdote, but it's like it's understanding the business. You can only understand the business by actually learning from people that are more versed than you, people that have experience in that particular stuff. Also, again, you can also take courses, like I said, just to help you ramp up. But yeah, those are what I would suggest, and also community, right? If you're in a community, and I'm guessing this is a community, so yeah, so this should be a good example, right? So if you're in a community, you may be a whole data community, but people are in different spheres and people are at different experience levels and would also be able to assist you and help you ramp up as well.
All right. Thank you so much for that. I don't have any question from my end. I don't know if anybody in the audience have any questions, or if not, you can reach out. You can follow Dami on LinkedIn. Just search for Damilare A dots. You see him, right? It's the same face that you are seeing now that you see on.
Yeah, it's still the same face.
Yeah. So, but when I'm also, sending the recording to the community, I will add this LinkedIn handle there so that you can connect with him. And then, again, the most important thing is when you want to break into an industry, connect to the people in that industry, right? So for anybody that is looking into the finance space, I mean, Damilare is like one of the leads in that area. Me is anywhere there is money. So if finance is where money is tomorrow now, the rest assured that I'll be in his DM and I'll be disturbing him. Thank you so much, Damilare, for coming to share your experience with us. We really appreciate your time, and yeah, thank you so much. All right, guys. I need to go now, so we'll talk more in our small community. Okay, now. Bye, everyone.
All right.